This is the second video on time domain representation of linear time invariant systems. This video is going to cover about the solution of linear time invariant systems. Linear time invariant systems time domain representation could be done using convolution integral or convolution sum. It could be done using linear constant coefficient differential equation or the difference equation, which is the discussion of this particular video. It could be done using block diagram representation, and it could be done using the state variable representation. In order to consider the complete solution of the difference or differential equations, we will quickly recall some of the examples for particular solutions in the CT example and the DT example respectively. Let us go on to the first example. In the first case, the problem that is considered is d squared by dt squared y of t plus 5 into d by dt of y of t plus 4 into y of t is equal to d by dt of x of t. y0 minus is going to be equal to 0, d by dt of y of t at t equal to 0 is going to be 1, and x of t is going to be equal to sin t ut. On solving this, the particular solution is of the form a sin t plus b cos t. The solution is obtained as 5 by 34 sin t plus 3 by 34 cos t. This solution will be considered for solving the complete solution. The next problem is going to consider the differential equation of the form d squared y by dt squared y of t plus 6 into d by dt of y of t plus 8 into y of t is equal to 2 into x of t. With the initial conditions given here, y0 minus is going to be equal to minus 1, d by dt of y of t at t equal to 0 is 1, and x of t is going to be equal to e power minus t u of t. The solution obtained for the particular case is yp of t is going to be of the form k into e power minus t u of t. That is going to be given by, that's equal to 2 by 3 e power minus t u of t. Next we go on to an example in the discrete time case where the particular solution has been found. Y of n minus half y of n minus 1 is equal to 2 into x of n. Y of minus 1 is 3 and x of n is minus half power n into u of n. The particular solution obtained for such a problem is yp of n is equal to k into minus half power n into u of n. In order to obtain the complete solution, some steps are required. Let us try to understand those steps which is necessary to obtain a complete solution for a differential equation or a difference equation. Hence, yh of t or yp of t or n is not described. The first step is determine the form of the homogeneous solution yh. The next is from the roots of the characteristic equation. The next is we need to determine the particular solution yp, assuming the same form as the input, and this should be independent of the homogeneous solution. The last case is we need to determine the coefficients in y of h so that the complete solution satisfies the initial conditions. With these three steps, we will go on to consider how the complete solution is obtained for a differential and difference equation respectively. Go on to the first problem. The first problem is the problem that we have discussed for solution in the particular solution case. t squared by dt squared y of t plus 5 into d by dt of y of t plus 4 y of t is equal to d by dt of x of t. y0 minus is equal to 0 and d by dt of y of t at t equal to 0 is 1. X of t is sin t u of t. Considering this in the characteristic equation form, it could be represented as r squared plus 5r plus 4 is going to be equal to 0. Thereby, the roots of this equation are r is equal to minus 4 and r is equal to minus 1. Hence, the homogeneous solution in the continuous time case is given by yH of t is equal to c1 e power minus 4t plus c2 e power minus t. The particular solution has been discussed in the previous case and it has been given here as the particular solution is obtained as 5 by 34 sin t plus 3 by 34 cos t. This is what we have considered so far. In order to get the complete solution considers the particular solution and the homogeneous solution as a complete value. Hence, y of t should be obtained as 5 by 34 sin t plus 3 by 34 cos t, which is the particular solution, and plus c1 e power minus 4t plus c2 e power minus t, which is going to be the homogeneous solution case. In order to obtain the values of c1 and c2, let us try to substitute the values. At t equal to 0, it is 0, hence we are going to get it as sin 0 is 0, so cos 0 is 1, so we get it as 3 by 34 plus c1 e power minus 4t, when t is 0, e power 0 is 1, so plus c1 plus c2. This is how we have got the first value. The second value tells us that d by dt of y of 0 at t equal to 0 minus is 1. So when we differentiate sin t, we get it as cos t. Hence we get that constant 5 by 34. Cos t becomes sin t, which is going to be 0, minus 4c1, that is the differentiation of this particular term, minus 4c1 minus c2. So this is what we have got as two expressions. In other words, minus 3 by 34 is equal to c1 plus c2, and 1 minus 5 by 34 is equal to minus 4c1 minus c2. On solving, we get that c1 is equal to minus 13 by 51 and c2 is equal to 1 by 6. Thus, the complete solution of the problem is 5 by 34 sin t plus 3 by 34 cos t minus 13 by 51 e power minus 4t plus 1 by 6 e power minus t. What is it that is different from the homogeneous solution case? There we used to substitute the initial conditions and consider it individually. Here it is a combined process, thereby giving the complete solution for the continuous solution case. Next, let us go on to consider one more problem to understand the complete solution fully. The problem is d squared by dt squared y of t plus 6 into d by dt of y of t plus 8 into y of t is going to be equal to 2 into xt. The initial conditions are given as y0 is going to be minus 1, d by dt at y of t equal to 0 is 1, and x of t is going to be equal to e power minus t ut. When we try to form the characteristic equation, we get it as r squared plus 6r plus 8 is going to be equal to 0. Hence, the characteristic roots are r is equal to minus 4 and r is equal to minus 2. The homogeneous solution for such a problem is got as yH of t is going to be equal to c1 e power minus 2t plus c2 into e power minus 4t. The particular solution has been obtained from the previous discussion as yp of t is going to be equal to k into e power minus t ut, which is going to be 2 by 3 e power minus t u of t. Hence, the complete solution is going to look like this: 2 by 3 e power minus t ut, which is the particular solution case, and c1 e power minus 2t plus c2 e power minus 4t, which is going to be the homogeneous solution case. Now, substituting the initial conditions to get the values of c1 and c2, y0 minus is going to be equal to minus 1 that's equal to 2 by 3 plus C1 plus C2, and d by dt of y0 minus at t equal to 0 minus will be equal to 1, which is giving us as minus 2 by 3 minus 2c1 when we differentiate it minus 4c2. Thus, the values of C1 and C2 on substituting and solving these two simultaneous equations are obtained as C1 is equal to minus 5 by 2 and C2 is equal to 5 by 6. Thus, the complete solution for this particular problem is y of t is equal to 2 by 3 e power minus t minus 5 by 2 e power minus 2t plus 5 by 6 e power minus 4t. Next, we go on to an example in the discrete time case. In the discrete time case, y of n minus half y of n minus 1 is equal to 2 power xn is the problem that is considered, and the initial conditions considered are y minus 1 is equal to 3 and x of n is going to be equal to minus half power n u of n. The characteristic equation of this particular case is, it is not a second order difference equation, it is a first order, so r minus half is going to be equal to 0. Hence, the homogeneous solution is yh of n is c into half power n. The particular solution has been considered in the earlier case as yp of n is going to be equal to k into minus half power n u of n, and this has been brought in here. Let us now substitute the particular solution value in the expression of y of n minus half y of n minus 1 is equal to 2 power x of n, which is the actual differential equation. The particular solution is k into minus half power n, so y of n is k into minus half power n minus half k minus half n minus 1, to have it for this n minus 1, is equal to 2 into minus half power n. Un is 1, so only this value is considered. Hence, y of 0 is going to be equal to 2 plus half into y of minus 1, which is given as 3. Hence, this value is 7 by 2. The overall solution is y of n is going to be equal to minus half power n u of n plus c into 1 by 2 power n u of n. On substitution, we get it as 7 by 2 is equal to 1 plus c when n is equal to 0. Thereby, we get that the value of c is equal to 5 by 2. So, the complete solution for this particular problem is y of n is equal to minus half power n u of n plus 5 by 2 into 1 by 2 power n u of n. Let us go on to another problem in the discrete time case. Y of n minus 3 by 4 y of n minus 1 plus 1 by 8 y of n minus 2 is equal to 2 into x of n. The initial conditions given are y of minus 1 is 1, y of minus 2 is minus 1, and x of n is 2 into u of n. The characteristic equation of such a problem is r squared minus 3 by 4r plus 1 by 8 is equal to 0. Hence, the values of the characteristic roots are r is equal to 1 by 4 and 1 by 2. Thus, the homogeneous solution turns out to be yh of n is equal to c1 half power n plus c2 1 by 4 power n. The particular solution is going to be yp of n is k into u of n. On substituting this particular solution, k minus 3 by 4k plus 1 by 8k is going to be equal to 4, giving the value k is equal to 32 by 3. Hence, the particular solution is yp of n is equal to 32 by 3. Hence, the complete solution now turns out to be y of n is equal to 32 by 3 u of n plus c1 half power n plus c2 1 by 4 power n. Let us apply the initial conditions to the expression y of n is equal to 3 by 4 yn minus 1 minus half minus 1 by 8 y of n minus 2 plus 2 into x of n. Y of 0 is equal to 3 by 4 into y of into 1 minus 1 by 8 into minus 1 plus 2 into 2, which gives us 39 by 8, because y of minus 1 is 1 and y of minus 1 is 1 and y of minus 2 is minus 1. Thus we get the value as 39 by 8. For the second case, when y of n becomes equal to 1, y of 1 is 3 by 4 into 39 by 8, which is the condition when it is 0, minus 1 by 8 at 1 it is 1, at minus 1 it is 1, plus 2 into 2, giving the value 241 by 32. Thus the expression becomes 39 by 8 is equal to 32 by 3 plus c1 plus c2, that is for y of 0, and for y of 1 it becomes 241 by 32 is equal to 32 by 3 plus c1 by 2 plus c2 by 4. That is when n equal to 1. This is when n equal to 0. Thus, on substituting these two expressions, the values that are got are c1 is equal to minus 27 by 4 and c2 is equal to 23 by 24, the solution of these two simultaneous equations. Thus, the complete solution is y of n is equal to 32 by 3 u of n minus 27 by 4 into 1 by 2 power n plus 23 by 24 into 1 by 4 power n. Next, let us go on to a slightly different concept on the complete solution case termed as natural response and forced response. The output of a system, either in the differential equation case or the difference equation case, could also be described by two more components, namely the natural response and the forced response. The natural response, as the name indicates, it is only associated with the natural case, which means only with the initial conditions, and it is generally denoted by y of n. This n tells us that it could be either for discrete time case or for the continuous case. And in the case of the forced response, the output is associated only with the input, and it is generally described by yf. Thus, the complete output in this particular case would be obtained as y is equal to yn plus yf. With this basics of natural response and forced response, let us just go on to see little more about what is natural. It is the system output for zero input as described in the previous case, and the output, as has been mentioned, is associated only with initial conditions. However, the main thing about the natural response is that it describes the method in which the system dissipates the stored energy or the memory of the past, represented by zero initial conditions. It does not involve a particular solution. It has only the homogeneous solution always. The natural response is generally got by considering the initial conditions, and an important concept is the initial conditions are not translated forward in time, which means we will be considering only the basic initial conditions. Let us go on to the problem of determining the natural response given a differential equation of the form d by dt y of t plus 10y of t is equal to 2xt. y0 initial conditions is 1 and the input x of t is u of t. Hence, the characteristic equation is r plus 10 is going to be equal to 0. Thus, the root is minus 10 and the natural response solution is C1 e power minus 10t. When t equal to 0, the value of C1 will be 1 as we substitute it in this particular expression that 1 is equal to, when t equal to 0, this becomes C1. So 1 is equal to C1, hence C1 is 1. Thus, the solution of the natural response is yn of t is equal to e power minus 10t. Let us go on to the problem to determine the natural response given d squared by dt squared y of t plus 6 into d by dt of y of t plus 8 into y of t is going to be equal to 2 into x of t. The initial conditions given are y0 minus equal to minus 1, d by dt of y of t at t equal to 0 is equal to 1, and the input x of t is going to be equal to e power minus t u of t. We need to determine the natural response. So, the first step is in determining the characteristic equation and the roots of the characteristic equation, which will be r1 plus 4 is going to be equal to 0. So, r1 is equal to minus 4 and r2 plus 2 is going to be equal to 0. Hence, r2 will be equal to minus 2. Thus, the natural response solution is yn of t is going to be equal to c1 into e power minus 4t plus c2 into e power minus 2t. And substituting the initial conditions, y of 0 is going to be minus 1 and d by dt of y of t at t equal to 0 is 1. For minus 1, we get it as c1 when t equal to 0 will be c1. C2 when e power minus 2t at t equal to 0 will be 1. So C1 plus C2 is going to be equal to minus 1. Similarly, on differentiating the above expression, we will be getting here from d by dt of y of t is 1 at t equal to 0. So we have substituted 1, and here we are differentiating this expression minus 4c1 minus 2c2. This is the expression that we have. So we have two simultaneous equations, c1 plus c2 is equal to minus 1 and minus 4c1 minus 2c2 equal to 1. Thus, the solution is c1 is equal to half and c2 is equal to minus 3 by 2. Thus, the natural response for this particular problem is yn of t is going to be equal to half into e power minus 4t minus 3 by 2 e power minus 2t. Next, let us go on for another problem given by y of n minus 1 by 9 yn minus 2 is equal to x n minus 1. The initial conditions given are y of minus 1 equal to 1, y of minus 2 is equal to 0 and x of n is equal to u of n. Determine the natural response of such a system. Hence, the characteristic roots are r squared minus 1 by 9 is equal to 0, resulting in r1 is equal to 1 by 3 and r2 is equal to minus 1 by 3. So, the solution for such a problem will be yn of n is equal to c1 1 by 3 power n u of n plus c2 minus 1 by 3 power n u of n. Substituting the initial conditions, y of minus 1 is 1. Hence, 1 is equal to c1 1 by 3 power minus 1 plus c2 minus 1 by 3 power minus 1. Similarly, y of minus 2 is going to be equal to 0 as per the problem for finding the natural response, that's equal to c1 1 by 3 power minus 2 plus c2 minus 1 by 3 power minus 2. Thus, the solution is c1 is equal to 1 by 6 and C2 is equal to minus 1 by 6. Thus, the natural response of this particular problem is yn of n is equal to 1 by 6 into 1 by 3 power n u of n minus 1 by 6 into minus 1 by 3 power n u of n. Next, let us go on for one more problem on finding the natural response in a discrete time case. The question given is y of n minus 3 by 4 y of n minus 1 plus 1 by 8 y of n minus 2 is equal to 2 of xn. The initial conditions given are y of minus 1 is 1, y of minus 2 is minus 1 and x of n is 2 into u of n. The characteristic roots are 1 by 4 and 1 by 2. Thus, the solution for such a problem in the natural response case, which is the question asked, is yn of n is equal to c1 1 by 2 power n u of n plus c2 1 by 4 power n u of n. Now, what is going to be our difficulty? Our problem is in, as is the usual case, determining the coefficients c1 and c2. Let us try to see how we can find c1 and c2. Let us try to substitute the two initial conditions. Y of minus 2 is equal to minus 1, resulting in c1 1 by 2 power minus 2 plus c2 1 by 4 power minus 2. Similarly, y of minus 1 is 1 as per the question, that is 1 by 2 power minus 1 plus c2 1 by 4 power minus 1. Hence, the coefficients are, on solving these two equations, c1 is going to be equal to 5 by 4 and c2 is equal to minus 3 by 8. Thus, the complete natural response solution is yn of n is equal to 5 by 4 1 by 2 power n u of n minus 3 by 8 1 by 4 power n u of n. On substituting in this particular equation, we are substituting the values of c1 and c2 given by 5 by 4 and minus 3 by 8. Next, let us go on to see what is this forced response. In a forced response, the major concept that we need to consider is that the system output is for zero initial conditions. The forced response has almost the same form as the complete solution of the differential or difference equation. The only difference that we see is the system is at rest when it is with zero initial conditions, as no stored energy or memory is there in the system, and hence the system behavior is described by the input only when the system is at rest. Thus, this depends on a particular solution, which is true only for t greater than 0 or n greater than 0, which is the difference with respect to the complete solution which we have determined in the earlier case. Similarly, when we consider the initial conditions, in the previous cases the entire initial conditions were considered. However, here the conditions before t equal to 0 or n equal to 0, which is under consideration, will not be considered. And as a result, to get the initial conditions at t equal to 0 plus and 0 minus as equal to 0, only inputs that do not result in impulses on the right hand side of the differential equation will be considered. Let us go on to the problem to determine the natural response given d squared by dt squared y of t plus 6 into d by dt of y of t plus 8 into y of t is going to be equal to 2 into x of t. The initial conditions given are y0 minus equal to minus 1, d by dt of y of t at t equal to 0 is equal to 1, and the input x of t is going to be equal to e power minus t u of t. We need to determine the natural response. So the first step is in determining the characteristic equation and the roots of the characteristic equation, which will be r1 plus 4 is going to be equal to 0. So r1 is equal to minus 4 and r2 plus 2 is going to be equal to 0. Hence r2 will be equal to minus 2. Thus the natural response solution is yn of t is going to be equal to c1 into e power minus 4t plus c2 into e power minus 2t. And substituting the initial conditions, y of 0 is going to be minus 1 and d by dt of y of t at t equal to 0 is 1. For minus 1, we get it as c1 when t equal to 0 will be c1, c2 when e power minus 2t at t equal to 0 will be 1. So c1 plus c2 is going to be equal to minus 1. Similarly, on differentiating the above expression, we will be getting here from d by dt of y of t is 1 at t equal to 0. So we have substituted 1, and here we are differentiating this expression minus 4c1 minus 2c2. This is the expression that we have. So we have two simultaneous equations, c1 plus c2 is equal to minus 1 and minus 4c1 minus 2c2 equal to 1. Thus the solution is c1 is equal to half and c2 is equal to minus 3 by 2. Thus the natural response for this particular problem is yn of t is going to be equal to half into e power minus 4t minus 3 by 2 e power minus 2t. Let us go on to the next problem considering the forced response in the continuous time case. The question is, given the differential equation, we are asked to determine the forced response for this particular problem. The question is d by dt of y of t plus 10yt is going to be equal to 2 into x of t, y0 minus is equal to 1 and x of t is going to be equal to u of t. The particular solution is yp of t is going to be equal to k into u of t. Considering the expression d by dt of y of t plus 10y of t is going to be equal to 2 into x of t, substituting the particular solution, we will be getting 10 into yp of t will be equal to 2 into u of t, that is 2 into 1. So 10k will be equal to 2, k will be equal to 2 by 10 or that will be equal to 1 by 5. Thus the particular solution is yp of t is going to be equal to 1 by 5 u of t. Next, let us go on to consider the forced response. In order to consider the forced response, yf of t is going to be equal to 1 by 5 u of t plus c into e power minus 10t, which will be the natural response of this particular expression. So, for the forced response, we are going to equate the initial conditions to be 0, which means yf of 0 is going to be equated to 0, and that is going to be equal to 1 by 5 plus c when t equal to 0. Thus, c will be equal to minus 1 by 5. C is equivalent to k here. So, it has been written as k is equal to minus 1 by 5. Since at t equal to 0, u of t is like an impulse, we have considered the input. Thus, the solution is yf of t is going to be equal to 1 by 5 minus 1 by 5 e power minus 10t. Let us go on to consider another problem to determine the forced response in the continuous time case. The problem given here is d squared y by dt squared y of t plus 6 into d by dt of y of t plus 8 into y of t is going to be equal to 2 into x of t. y0 minus is minus 1 and d by dt at y of t equal to 0 is 1. the initial conditions are given and input is given as x of t is equal to e power minus t u of t. The characteristic roots of the equation are r1 plus 4 is equal to 0, giving r1 is equal to minus 4, and r2 plus 2 is equal to 0, giving r2 is equal to minus 2. The particular solution for the problem is yp of t is going to be equal to k into e power minus t u of t, giving the result 2 by 3 e power minus t u of t. This has been already considered in the previous cases, or else also the particular solution can be easily determined. The forced response of this problem is 2 by 3 into e power minus t u of t, which is the particular solution, plus the natural response, which is c1 into e power minus 2t for this particular root, and c2 into e power minus 4t for this particular root. Thereby, the forced response has the particular solution and the natural response. Let us see how to determine the forced response. In order to consider the forced response, one of the major things that we need to consider is the initial conditions need to be considered to be 0. That means y of 0 minus is going to be equal to 0, and d by dt at y of t equal to 0 is going to be equal to 0. Thus, yf of t is going to be equal to 2 by 3 e power minus t ut plus c1 e power minus 2t plus c2 e power minus 4t. Let us substitute for this. Yf of 0 is 0, hence we will be getting 2 by 3 plus c1 plus c2, or c1 plus c2 is equal to minus 2 by 3. Similarly, let us try to differentiate the equation and equate it to 0. So, 0 is going to be equal to minus 2 by 3. The differential of this is minus 2 by 3. At t equal to 0, this is 1 minus 2c1 minus 4c2. So, the solution is minus 2c1 minus 4c2 is going to be equal to 2 by 3. Thus, we have two simultaneous equations. c1 plus c2 is equal to minus 2 by 3, and minus 2c1 minus 4c2 is going to be equal to 2 by 3. Solving these two, we get c1 is equal to minus 1 and c2 is equal to minus 1 by 3. Let us now try to substitute this in the expression for the forced response. So, the forced response now becomes yf of t is equal to 2 by 3 e power minus t u of t minus 1 from here, e power minus 2t minus 1 by 3 e power minus 4t. This is the solution for the problem given above. Let us consider one problem on forced response to determine the forced response in the discrete time case. The question given is y of n minus 3 by 4, y of n minus 1 plus 1 by 8, y of n minus 2 is going to be equal to 2 into x of n, where the initial conditions given are y of minus 1 is 1, y of minus 2 is minus 1, and x of n is 2 into u of n. Trying to get the characteristic roots of this particular expression, which has got minus 3 by 4 and plus 1 by 8, the roots are r minus 1 by 4 into r minus half. Thus, the roots will be r is equal to 1 by 4 and r is equal to 1 by 2. Let us now try to determine the particular solution for this problem. It turns out to be 32 by 3 into u of n. The forced response is going to be equal to the particular solution plus the natural response, which is 32 by 3 into u of n plus c1 into the roots are 1 by 2 power n plus c2 1 by 4 power n. Now, how are we going to determine the values of c1 and c2? In order to determine the values of c1 and c2, let us first try to determine the initial conditions when n is equal to 0 and when n equal to 1. Substituting this in the expression here, we will be getting when n equal to 0, this is y of 0 minus 3 by 4 y of minus 1 as has been given here plus 1 by 8 y of minus 2, and the input here is 2 into 2un, which means 4. So that is why 4 has been written, because that is like an impulse at n equal to 0. Such an input can be considered. So y of 0 is going to be equal to 2 into this 2, that is how we are getting the 4. So y of 0 is going to be equal to 4. We can see that y of minus 1 and y of minus 2 are 0. Next, let us try to obtain for n equal to 1. When n equal to 1, it is y of 1 minus 3 by 4 y of 0 plus 1 by 8 y of minus 1. We can just consider the immediate value before, that's why we have considered y of 0. Y of 0 is 4 from here, so minus 3 by 4 into 4, which is minus 3. So y of 1 will be equal to 2 into 2, this is 4 as before, even when n equal to 1. So y of 1 minus 3 is equal to 4, or y of 1 is equal to 7. These are the initial conditions obtained from substituting the difference equation with the respective initial conditions if applicable. Since it is a unit step, it is applicable, hence we have got these values. Next, let us now try to get the complete solution with the forced response. So we are going to equate this with the forced response. So 4, the first case is y of 0 is going to be equal to 4. So 4 is going to be 32 by 3. When n is 0, this is 1, plus when n is 0, this is going to be 1 plus c1. Similarly, when n is 0, this is also going to be 1. So plus c1 plus c2. What happens when n is equal to 1? When n is equal to 1, we have got that from the difference equation the value is 7, and from here we will be getting it is going to be equal to 32 by 3 as shown here, plus c1 into 1 by 2 power 1, that is 0.5. Similarly, plus c2 1 by 4 power 1, that is 0.25. So we are going to get the expression as 7 is equal to 32 by 3 plus 0.5 c1 plus 0.25 c2. Now let us try to solve these two simultaneous equations. 4 minus 32 by 3 is equal to c1 plus c2, and 7 minus 32 by 3 is equal to 0.5 c1 plus 0.25 c2. On solving, we get c1 is equal to minus 8 and c2 is equal to 4 by 3. Thus, the complete forced response for this particular discrete time problem is yf of n is equal to 32 by 3 u of n minus 8 into 1 by 2 power n for c1, plus for c2 it is 4 by 3, so 4 by 3 into 1 by 4 power n u of n. Next, let us go on to one more problem on forced response. The problem given is y of n minus 1 by 9, y of n minus 2 is going to be equal to x of n minus 1. The initial conditions given are y of minus 1 is equal to 1, y of minus 2 is equal to 0, and x of n is equal to u of n. So r squared minus 1 by 9 is equal to 0. The roots are r is equal to 1 by 3 and r2 is equal to minus 1 by 3. The particular solution is given here. Yp of n is equal to k into u of n, y of n minus 1 by 9, y of n minus 2 is equal to x n minus 1. Thus, substituting we will get k minus 1 by 9k is equal to 1, or k is equal to 9 by 8. Thus, the particular solution is 9 by 8 u of n. Now, the forced response is going to be equal to particular solution plus the natural response. So 9 by 8 into u of n plus a constant c1 into the first root is 1 by 3 power n plus c2, the second root is minus 1 by 3 power n. Now let us try to obtain the values of the discrete time equation when n equal to 0 and n equal to 1. When n equal to 0, we are going to get this expression as y of 0 minus 1 by 9 y of minus 2 is going to be equal to x of 0 minus 1. This results in x of minus 1. X of minus 1 is undefined, so y of 0 becomes equal to 0. Similarly, when n equal to 1, this becomes y of 1 minus 1 by 9. Y of minus 1 will be equal to x of 0. X of 0 u of n is like an impulse, so it's going to be equal to 1. So y of 1 is going to be equal to 1, whereas this is equal to 0. These initial conditions which are given here will not be considered. That is the speciality of the forced response. And hence, now let us try to apply these two initial conditions, y of 0 equal to 0 and this is equal to 1, to this particular expression when n is equal to 0. When n equal to 0, this will be 9 by 8 plus c1 plus c2. That will be equal to, as is given in the other case, y of 0 is 0, so this is equated to 0. Similarly, when n equal to 1, the value here is 1. That will be equal to, let us substitute in the forced response n equal to 1, 9 by 8 plus 1 by 3 c1 minus 1 by 3 c2. This is minus 1 by 3 c2. Thus, let us try to solve the two simultaneous equations. Minus 9 by 8 is equal to c1 plus c2 and 1 minus 9 by 8 is equal to 0.33 c1 minus 0.33 c2. Thus, we get c1 is equal to minus 3 by 4 and c2 is equal to minus 3 by 8. Let us now complete the problem by substituting the values of c1 and c2 in the expression for forced response, thereby getting yf of n is equal to 9 by 8 into u of n minus 3 by 4 into 1 by 3 power n u of n minus 3 by 8 for c2 into minus 1 by 3 power n u of n. That completes the problems for natural response, forced response and the complete solution. We need to consider what is the relation between the complete solution and the forced response. Here are our references: Simon Haken and Openhat.